Well, hello, seventh graders. L84 Algebraic Terms. Very excited about this lesson. Really starts to open us up into next year. Very important lesson in which we get to start talking. Was it for you? Monday. Happy Mondays. It's not anywhere near Monday for me, but I'm kind of happy about that. But it is from you. So today we're going to talk about something called polynomials, which I may have given a little bit of lip service to. And we can define just simply polynomial as an algebraic expression involving one or more terms. We'll get into a deeper definition next year, but for right now, that will suffice. And we have three types of polynomials that we're going to talk about, but really there's even though we only give names to three of them, there's an endless amount of them. So there's something called, when we consider polynomials, we have something called a monomial, we have something called a binomial, and we have something called a trinomial. And I know how deeply rooted our language is in both Latin and Greek, so I'm sure you know what those things already mean. So monomial, like monotheism, the belief in one God, means that our term would just be something like that. Like it could just be x to the seventh. It's just a single term. Or I could have something like 8p. That's a monomial. Another one could be a little bit more complex, like negative 21, a to the sixth, b to the third, c. Those are all considered monomials. They're considered single terms, Now, binomial would mean something different. You can probably tell, think about like bicycle and things like bifocals and things like that. So this is what a binomial will look like. Something like x plus, let's say, 2. That's a binomial. Here's another one, 4p minus 3. That's a binomial. Notice how it has how many terms. Here's the last one. Let's go with 8x squared minus 7x. Again, those are two terms, and they cannot be collected because they're not like terms. Therefore, it's a binomial, and a binomial is something that has two terms. And I'm sure you can guess what a trinomial would be. Think of a tricycle, right? Or what other tri things are there? Triskaidekaphobia, which is the fear of the number 13. Yeah. So that obviously would have three terms, and one might look like this, where you'd say, okay, 5x squared minus 4x plus 7. That's a trinomial. Another one might be a plus b minus 2. That's a trinomial as well. Because it all kind of comes down to a big idea that we've talked about before. And that big idea is what's called like terms. And hopefully when I say like terms to you, like 6 words pop into your brain, because that's what I want, that Pavlovian response. But like terms are basically when we think about the same variable to the same...
Let me know how much that is.
All right, I got a little cut off there. So like terms, we want 6 words. Same variable to the, do you remember? That's kind of the important part, to the same degree. And remember, degree has to do with exponents, right? Whatever the exponent is, that's the degree of a term. So when we think about like terms, and I know we looked at these examples before, but what if I had something like 8x minus 7y plus 2x? Well, I have to think about same variable. So when I consider this 8x and this 2x, those have the same variable. They're also to the same degree. They're to the degree of 1 if you're interested. And because they're like terms, then I can do what's called combine or collect them, which is basically like adding and subtracting. You got to ask yourself battle questions. Clearly, this is not a battle, and so they would join forces at 10x. And this negative 7y doesn't have a like term to be collected with, so that would be it. And I cannot smash these together anymore. That's as good as it gets. Maybe a more complex example might be something like this, 2x squared plus 3x minus x. So again, when I look at that second degree, so that's, see how it has a 2? So that's the degree. It's the degree of 2, or the second degree. That 2x squared doesn't have a like term. So I'd end up just rewriting it, like I can't make him go away, but he's got nothing to collect him with. And then I think about my first degree, which is that 3x and that negative x. And again, you got to ask yourself battle questions. And most importantly, you got to remember the sneaky, yeah, you know it, the sneaky 1. There's a 1 there. So I say, is it a battle? Yes. Who's going to win? The pause is by how much? Well, by 2. So positive 2x. And again, even though those are both x's, they're the same variable. They're not to the same degree. So I have to become comfortable with going, boom, that's it. I can't do anything more with those because they're not like terms, right? All right. So there is a Pavlovian phrase I need, and it's this. We've said it before. We collect like terms. Anybody want to help me out? Yes? Okay, good. Thank you. You got the first one. We collect like terms whenever. And let's go whole class on the last thing. Count of three. Ready? 1, 2, 3. We collect like terms whenever. Yeah, possible. That's right. So let's look at a problem that they have for us. Here it is. 3x plus y plus x minus y. And the directions here are very simple. They just say simplify, which as we know, that means we're going to represent this in as few as symbols as possible. So I'm going to focus on the x first before the y because that's how the alphabet works. And that's generally a nice little plan. It's not the only plan, but we could do it today. And I'm going to just ask myself, hey, does this 3x have a like term? Well, sure it does. Right over here, that positive x. Is it a battle? No. Who's going to win? I mean, they're going to join forces at, remember the sneaky one, so that would be 4x. Then I'm going, okay, there's no more x's to deal with. Now let's think about my y's. I have a positive y and a negative y. Is that a battle? Yes. Who's going to win? Well, this is the sad battlefield. No one wins. So we're not going to bother writing that. We're not going to put plus 0. We just simply simplify this whole thing to 4x. And that's it. Ain't no more to do. Hey, let's do another one. Well, let's go ahead and write it down. 3x plus 2x squared plus 4 plus x squared plus x minus 1. Now, there's something called descending order. You don't have to write that into your notes, but we'll continue to kind of explore it as we move forward. Descending order means that we're always going to think about our highest degree first when collecting. The directions here are simple. They're simplify. So what we want to think about is our highest degree, and that is of the second degree. And we have this term, this 2x squared is of the second degree, and also this x squared. And they're both of the second degree. They're both the same variable. Therefore, they can be collected. Sneaky one, remembering, we'd have to say that those simplify to simply 3x squared. We go on from the second degree to the first degree. Do you see anything of the first degree? I hope you do, because I see this 3x is of the first degree, and also this positive x is of the first degree. Ask myself battle questions. It ain't a battle. And they're going to join forces, remembering the sneaky one, they're going to join forces at positive 4x. Make sure to use that positive symbol. It's very important. And then you might go, oh, are we still kind of talking about variables? Well, it's kind of a strange thing. With constants, which is the 4 and the negative 1, those are called constants. I know we've talked about that before. You might go, well, they don't have a variable on them. They kind of actually do. And I don't want to mess you up or anything like that. I'll talk about it in just a moment. But they do. But right now, we can always collect constants. That's always been the case. And we should ask ourselves the battle question. So I got a positive 4. I got a negative 1. Is it a battle? Yep. Who's going to win? The positives by how much? 3. And then I can box up. Yeah. So here's kind of the thing that I was talking about here, this 4 and this negative 1. This is something we don't really need right now, but later on in our math life, we will. So the way they'd show this is actually, theoretically, this 4 does have a variable, but it's not to the second, and it's not to the first. It's actually to the, can you guess for the sticker? Yeah, nicely done, to the 0. Because remember what we learned, that anything to the 0 power is equal to 1. So 4 times x to the 0, well, x to the 0 is simply 1, and 4 times 1, guess what, is 1. So it is attached. Every constant's kind of attached to a variable to the 0 power. Kind of an interesting idea, huh? Well, it's a nerdy math idea, but it is an idea. L84. This is a good one. So it's Monday, so the homework will be the split, 83, 84. Again, anytime you need me, I'm happy to do video conferencing. If you're having trouble with an idea or just need to touch base, all you have to do is reach out to me by email and we can get that done. All right? Hope you're doing well. Take good care. Bye.